So is my screen visible? Hello, is my
Yes,
screen
yes, yes.
visible? Okay, thank you. So we were talking about tuples, and in last two class we have talked about tuple creation. So I'll not go in depth of tuple creation, but we know that tuple can be created using these brackets, and if you have to define only single element in a tuple, then you must give a comma. Then Python will understand that it is a tuple. All right, you can just check that T is a tuple. All right, we have seen this in the last two classes, and we also said that we can extract the element of a tuple, or yeah, access the element of a tuple using indexing. Like here, this tuple has only one character in the first position or 0th position, so you can see T0 you will get 1, but instead of T0, if you put any index which is not there in the tuple, then you will get an error. Right, you see tuple index out of range. So you must be sure you must have the length of the tuple before you indexed, and make sure that you are not indexing out of the range inside the tuple. All right, this is it, and we have also seen that we can slice over tuple. So if you have a long tuple like 1 comma 2 3 4 5 6 7 8 9, and then you do t 2 to 5, then you will get sliced tuple. All right, so this is all about so we have also seen that indexing can also be negative from backward direction. So it starts from -1 and goes up till whatever is the element in the first position is. All right, and you can print the all the elements of a tuple using just the colon, and you will get all the elements of the tuple. All right, so changing tuples position, sorry, changing a tuple. So I have told you this, but we have not seen what it means. So I told you that tuples are immutable, like strings are immutable. So tuple is a data type in Python that cannot be changed. All right, so it has certain advantages. That's why Python has this data structure tuple, because we have list, and list is also a collection of elements. As list can have multiple data types inside it, so it can have string or other lists also inside it. Tuples can also have integers or strings, tuples inside tuples, or lists, etc. But this is different from list, as in that you cannot change the element of a tuple once it is already defined. All right, and both tuples and lists are ordered sequence, so you can index inside it. When we are seeing that we are indexing, that we can index inside the tuple. All right, so we will see how what does it mean when we say we cannot change a tuple or tuple is immutable. So I have a tuple called T, and if you want to change this element, first element, to something else like S, then you cannot do this, and it will say tuple object does not support item assignment. It just means that tuple, you cannot change a tuple once it is already defined in the memory. But there is a slight catch over here. You see, you cannot um, alter the elements of a tuple. No, sorry, I did not mean that. I meant that you cannot modify the tuple, but if the tuple has an element which is mutable, then you can change that element of the tuple. For example, you see, I'll define this tuple, and I'll say that one of the position there is a list, and it has 1 2 3 4 5 4 4, yeah, and 6. So you see, in the, I'll delete some of the elements. In the 0 1 2 3, in the third position there is a list in this tuple, and you can check that when you do T3 you will get a list. All right, so in the third position of this tuple there is a list, and since lists are mutable, you can mutate this list. All right, so you see T3 is a list, and in suppose you want to change this 3 to 33, so this 3 is at second position. You can check, you see, you are actually accessing this 3 inside the list, and in that list inside that sorry, in the tuple inside that list. So inside this tuple you are accessing this element which is inside the list. and that list is inside the tuple, and you want to change this. So if you want to change this, you can do that, because the list in Python is mutable. So you want to change it to 33. So you can do that, and when you check, you see the original list is changed, which is inside the tuple, but you cannot change the position of this list or add elements to this tuple. All right, just 1 minute. I have to attend a call. Yes. So you can see that since this element is mutable, which is inside the tuple, you can actually modify that element inside that tuple, but you cannot change the structure of the tuple. So you cannot add one more element inside the tuple. All right. Since this element was mutable, you could mutate this tuple. You can also add, please be careful, huh? You can add elements in the list, but you see what I mean by this. You can do this. So T3 is a list. All right, you see, you can check T3 is a list, and you want to add an element inside the list. You can do that. You see, to T3 dot append, T3 dot append 4. You not 4. Let me add one more list inside that. So it is A, B, and C. You want to add one more element to the list. Which list? That list is inside the tuple, and you can do that. When you do that, and when you check the tuple, you see this is the original tuple, and in the third position, third index, it was a list, and this was the list. Inside this list, you have added an element. You have not modified the elements in the tuple. I mean to say, you are not adding more elements or changing the elements inside the tuple. You are changing that element which is mutable. All right. So this you can do. Any questions? Now, if you want to access B, you can do that. You see this list is inside the tuple, which is in the third position. You can do T3, and you will get this list. Inside this list is in the last position, so you can do T3 and -1, and when you do, you will get the last element, which is a list, and inside this list you want to get this element. You can do that, T3 -1 and 1. When you do this, you will get B. All right, I hope this was okay. Now you can also concatenate tuples. So if you have tuple T1 is equals to 1, 2, 3, and another tuple T2 is equals to 4, 5, 6, and you want to concatenate, it means you want to make one tuple which contains 1, 2, 3 and 4, 5, 6. You see, you can do that, but you will not be able to modify T1 and T2. You will have to make a new tuple. And if you go to Python tutor, you will see that these two tuples are not changed or modified. You have created one more tuple inside the memory. So you have to do T3 is equals to, T3 is equals to T1 plus T2. I guess this will work. Let me check. Yes, it worked. So you see, you have actually concatenated the tuple, but it is a new tuple. It has not modified T1 and T2. You can check T1 is same and T2 is also same. All right. And since tuples are immutable, so there are a little less functions which can be used with tuple as the number which was used in list. So list has more functions to it because you can modify the elements of the list. So there are a few less functions you can use for tuples. All right. So I'll go to that. Before that, is there any doubt in this? Changing a tuple and concatenating two tuples. All right. So I'll move on. So you see, you can delete a tuple inside memory. So suppose you have a tuple inside the memory and you do not require it. So you can delete the tuple inside the memory using del. So you see you have a tuple t1 inside the memory and you want to delete this tuple. So you can do that. You can use the keyword called del and you can say del t1. When you do that, you will delete t1 entirely from the memory, and when you check t1 you see name t1 is not defined because you have deleted entirely. If you remember, we had lists and we used del keyword there, and in that we could delete some elements inside the tuple using del keyword. So if you had a not tuple, if I said tuple, it was list. So you see, if this is a list and you want to delete 4 from this list, so you could do that by saying del list1 and passing the position, which is I guess I said 4, so it is in the 3rd position. And when you check what is list 1, you will see 1, 2, 3 and 5. This you cannot do when you use a tuple because tuples are immutable. All right, so if you check, we had t2 in memory. You can see we had t2 in memory, which is actually a tuple 4, 5 and 6. We had defined it in the memory, and if you want to delete only one element in the in t2, if you try to do that, you will not be able to do it. All right, so if you say del t2, whatever is in the 0th position, delete it, you will get an error. Tuple object doesn't support item deletion, but you can delete t2 entirely from the memory. All right, is it okay? Now we'll see. Yes, so we'll see how can you count the number of occurrence of some element in a tuple. So it is simple. Let me see if I have t in memory. Is it repeating some elements? No. So I'll define one more tuple. I'll say 1, 2, 3, 4, 1, 3, 1, 5, 6, 7, 78. All right. So I have a tuple inside the memory, which is this, and you can count the number of occurrence of some element. You see, you say you are counting number of occurrence of the element 1. So you can do that. 1 occurs 3 number of times. All right. So this is the frequency of a particular element that appears in a tuple. And if you try to count something which is not there inside the tuple, like 75, then it will say 0 because there is no occurrence of 75 inside this tuple. All right. So we have seen tuple indexing. I'll just delete it because we have seen it. Now, when we were talking about operators, so we talked about in operator. So you can use in operator to check if an element is present inside the tuple or not. You see, in T, we have an element called 78. So you can check 78 in, so you can say print 78 in T. So what this will do is it will check if this element 78 is inside the tuple or not. All right, and it will return true if it is there, and or return false if it is not there. So you see, we have got true. Similarly, if that element is not there inside the list, suppose 75, then you will get false. All right. Now we'll see some of the functions which are used for tuples. So we have already seen this function len, which tells you the number of elements inside some objects. So you can also use len when you are working with tuples. So you can say len t and you will get 10. So there are 10 elements inside this tuple. You can check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 elements are there inside this tuple. All right. Now we'll go to sort. You see, in list, when we were talking about list, we had a function called, so I had a list, no, I defined a list here. What is the list? List 1. So when I say list 1 and I see, yeah, it is a list which is 1, 2, 3. Let me add some more elements in this list. So it is 2, 4, 3, 6, 1, 7, 1, 3. All right. So this is the list. And now I had a function called sort, S-O-R-T. You see, it did not return anything. This function sort actually altered the list itself and it did not return anything. It returned none. Actually, it returned none. So when you do that, you will not get an output, but list 1 will be modified or altered. You see, it is 1 1 2 3 3 4 6 7, but tuples are immutable. Therefore, you will not be able to use this function sort, and you can check. You see, we have a tuple t. It is already, no, it is not sorted. Is it? No, it is not sorted. So we will say t. It is not sorted, and we'll say t dot sort, and we will get a error which says tuple object has no attribute sort. So there is no function called sort for tuples. In that case, you can use sorted. So when we used sorted, we saw that it returned an object which was sorted, but it did not alter the original object. So when we were talking about list, it returned a sorted list, but it did not alter the original list. In this case, it will not alter the tuple because tuples are already not mutable, so you will not be able to do that. But this function will not try to sort the original list. It will create a new list in the memory and sort the elements of that list and put it in that new list. All right. In this case, it is a tuple. So if you do sorted t, you will get, sorry, t was okay, and it returns list. Yes. So sorted actually sort the object and returns a list. I forgot this point. So it always returns a list. And when you check t, you will get, you see, it is not sorted, but whatever it returned, it is a sorted list. All right. Now you can also have some functions called max. So if you check max of t, you will get the maximum element or number which is inside the list. Sorry, not list, tuple. You can also have sum. You can also do min. You can also do min and other functions. All right. Now, in the last class, when we were talking about return from functions, so I told you that you can return 2 or more objects from a function using this tuple. All right. How did we do that? We said that x comma y equal to, and there was some function name, so I'll just write function name. This is actually a function call and some parameters, say a or something like that. And if this function returned a tuple, so it will be unpacked. So the first element of the tuple will be assigned to x, and the second element of the tuple will be assigned to y. You can use this concept, not the function call, but this assignment thing, and utilize it for your own benefit. All right. So you see what I'm saying. You see, you have two numbers, say x is equals to 5 and y is equals to 29. All right. And I have given you a task to swap these numbers. All right. So you are given a program or asked to write a program to swap these numbers. So what you will do, you will actually require a container in which you will put the value of one number and then change it. So I want to say that you will have to define something called temp. This is just a temporary variable to store that number. So you are storing the value of x, say, and you are saying that x is equals to y and y will be equal to temp. All right. So you have to do these 3 steps to actually alter the or swap the values of the number. And when you print x comma y, you will see that the values are swapped. X is actually 29 and y is 5. But using tuple makes it more easier to swap a number. You just have to do x comma y. This parenthesis is actually not required. All right, I have not told you this. No? You see, when we were talking about tuples and tuple creation, this parenthesis is not necessary. So if you want to say t is equals to 3, 4, 5, a, 10, r, all right. So this is a tuple. This will be a tuple. You see, you have not given the parenthesis, but still this will be a tuple. It will not give an error. All right. You see, this is a tuple. So this parenthesis is not necessary, but you can do that for your understanding. Similarly, so using this idea, if you go down, is this all right? No, parenthesis is not necessary when you are defining a tuple, but to make us clear that it is not a list and a tuple, we always give a this brackets, right? So if we go down, we were talking about swapping the numbers. So you can do that. X comma y is equals to y comma x. And what are we doing with this? You see, assignment always works from right to left. All right. So what it will do is it will assign this tuple to this tuple. So whatever the value of this tuple is, this tuple's value will be 29,5. And whatever this value will be assigned to the tuple which is in, on the left hand side of the assignment operator. In that case, 29 will be assigned to x and 5 will be assigned to y. And when you do this, actually we have changed the value of this. Before doing that, I have to redefine the values. And now x is 5 and y is 27. And when you do this and check the value of x comma y, you will actually get 29,5. All right. So you see, you have swapped the value of the tuple. And here also I have written a tuple but not written the parenthesis. That's why I'm getting a tuple. So if you don't write a parenthesis also over here, it will Python will understand that these two are tuples. All right. It is not absolutely necessary. But I'll go on and do the parenthesis because that is how we generally code. All right. Any questions? Now you see, why do we need something? Yeah. Any questions?
No, sir. No.
All right. So why are we talking about?
What is the difference between list and tuple, sir? I joined 5 minutes late.
Okay, no problem. But this is important to realize. You see, tuples and lists both are collection of objects. So it can either be a string, it can either be an integer, it can be a float, or it can be a compound data types as well. So it can have lists, it can have dictionaries, we'll see. It can have sets, it can have more tuples inside it. All right. So it is just collection of objects. The difference, and both lists and tuples are ordered. So it has index. All right. So tuples can be indexed and lists can be indexed because those are ordered objects. The sequence are ordered. So it starts from 0 and goes to the last element. The difference between tuple and list is tuples cannot be modified later on, or tuples are immutable. So I tried to do this. You see, I defined a tuple called what did I say? Yeah. So this is the tuple. So T is this. I'll say, I just redefine it. Sorry. I have this tuple. You can check. T is this tuple. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And what I tried to do is I tried to assign S in place of 3. So I wanted to change 3 to S. And when I did it, I got an error. Why? Because it says tuple object does not support item assignment, but the concept is not this. The concept is you are not able to change the object which is inside the tuple if it is immutable. So what do I mean by that? You see over here, this 3 is an integer and integers are immutable. All right. Not variable. This is not a variable. You can change the value of a variable, but this integer is immutable. You cannot change the integer itself. So you are trying to change that integer inside the tuple. You are not able to do that because this is a tuple and tuples objects cannot change once it is defined. But if inside the tuple there is an object which is mutable, over here I have defined a new tuple which has a list inside it in the third position. Since this list is mutable, so you can play around with this list, but you will not be able to change other elements of the tuple. All right. So you see T3 is a list. You can check. This is a list and I have accessed this element 3 and I want to change this element 3 to 33. So I did T32 is equals to 33. and when I checked, I got this list which is changed, which is not the original list, but the tuple has not changed. You see, it had 0, 1, 2, 3, 4, 5, 6 element, and it has 6 element after changing in the elements of the tuple. So you are not able to change those elements which are mutable or add new elements to the tuple. All right. Similarly, you can append some elements in this list. So I appended this list inside the list using t3.append. Why I could do that? Because t3 is a tuple. T3 is a tuple, sorry, T3 is a list. And since it is a list, I can use the function called .append and add some elements to that list. So I did it. When I did it, I got this, the new list. All right. And in this list, you have added the new element, which is this, but the original tuple is unchanged. And if you want to visualize this better, you can do that using Python tutor. So let me do that. It will be better for understanding. I have this tuple. Just 1 minute. Network is not good. So this is T, and I did this first. Then I did this. All right. So you see what is happening. First, I have defined a tuple in memory. So this is the tuple which has these elements 1, 5, 6, and this is actually pointing to a list inside the memory, and the other elements are 7, 8, and 9. Now this list is mutable actually, so you can do that. You can change the element of this list. So you see I have changed 3 to 33. Since this list is mutable, so this original tuple is also modified, because this element, the third element, is actually pointing to a tuple. Sorry, not tuple, pointing to a list. Again, I am modifying this list and I am adding some elements over here. So what did I do? In the 6th position, I add one more list in this list. So this position, 6th position, has a list which is this. All right. Since I have modified this list, the original tuple is also modified. So if you say print t, which I have done over here, print t, this is actually print t. So you'll get this. All right. Any doubt, ma'am?
Funny. No, clear, sir. Thank you, sir.
So this is important, and I hope you were here when we were talking about tuple deletion.
Yes, sir. Yes, I'm there.
All right. So we were saying, yeah, swapping. Okay. So we were here. So I'll show you one program, and we will see some advantages, some uses of how we can use lists, not lists, tuples. I'm sorry, I'm just confusing it again and again. So if you get confused, just point out. All right. So before we do that, what we can do is, you see, tuples are immutable, and you can define a tuple inside a tuple. All right. So you see, you can say that you are making some phone diary, and you are saying that the phone diary, you can say phone, 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 diary, diary, and you are saying that the first element of the tuple will be name, so it will be, say, Raj, and the second element will be the phone number, so it is 1, 2, 3. All right. And I'll define one more tuple. So the outermost is the phone diary, and the elements of this tuple is actually a pair of elements. So it is, first element is actually the name of the person, say Sean, and the other element is the phone number 4, 5, something like that. So you can do something like this. It is compound data type. You are trying to get more, store more information and make some sense. All right. So I'll just name one more Arjun, and the other phone number is something this. All right. So this is a phone diary, and you are storing tuples inside this phone diary. The first element of the tuple is the name, and the second element is the phone number. So I have defined the phone number in as a string. You can also do that using integer. It is up to you. Just for illustration purposes, I have told you this. But later on you will see there is more elegant way to do this when we go to dictionaries. So dictionaries are more powerful than using tuples. All right. Now we'll see this program. So what this program does is there is a function called process data. All right, and it accepts a tuple. And we will not see what it is doing. We'll come back to it when there is a function call. All right, and I am passing this data to it. And this data is actually a tuple of tuples. So the first tuple, or all the tuples inside this data, the first element is an integer and the second element is a string. So this is what the function accepts or expects. The function expects a tuple of tuples in which the elements have first element as number and the second element as string. So this will be the input of this function. It will be a tuple of tuples, and each element of the outer tuple is actually a tuple which contains a number and a string. All right. So this is what it expects. So if you give something else, it will give an error, but we have giving it proper data. All right, and we are calling this function. So what this function is trying to do, it is actually trying to get the number of occurrence of this words. So you see, when we execute this, it will say what it will do. It will try to get what is the string, and it will count unique occurrence of this string. So you see, apple has occurred twice. So it will say unique word count, which is 2. So this is one unique word and this is one unique word. So there are 2 unique words in this tuple. And it also checks what is the maximum and minimum value in integers you have given to it. So we are just passing this tuple to it, and you will see what it does. So this is 2 variables or tuples, which is first is number, which is an empty tuple, and word is also a empty tuple. So for each t in this data tuple, so what will t have? T will have individual tuples. So first t will have this tuple. In the second iteration, t will have this tuple, and in the third iteration, t will have this tuple. All right. Is this clear? In the first iteration, it will have this tuple. In the second iteration, it will have this tuple, and in the third iteration, it will have this tuple. Is this clear?
Yes.
All right. I
Yes,
hope
sir.
it is clear. Now this empty tuple I am assigning. So we had talked about concatenation of tuples. You see, when we did it, we said that you can concatenate 2 tuples using plus operator, and you have to assign it to other variable name. Otherwise, it will be lost because you are not able to modify these tuples. You have to store it somewhere. So we are doing that. What are we doing? Number is an empty tuple in the first iteration, and we are adding to it a tuple which is t0. So what is t? T in the first element is this. Sorry, t in the first iteration is this tuple, and t0 will be this number. So this is a tuple and this is a tuple. In the first iteration, number will have 1 as the first element. So for simplicity, if I print number comma numbers, you will be able to see what is happening. So in the first iteration, number is 1 comma. Why 1 comma? This is an empty tuple, and to this tuple we are adding a tuple which has the first element t0. What is t0? This is t in the first iteration of the for loop, and t0 will be 1. All right. In the second iteration, number has this tuple. Number is this tuple because we have assigned it to numbers, and t will be this tuple, and t0 will be 20. So 20 will be added to this tuple, and similarly in the third iteration, 21 will be added to this tuple. So we have a tuple which is the collection of the numbers in the data which we have passed to that function. All right. So we are just trying to get all the numbers in the data. In this if condition, I am saying that if t1 is not in word, because we want to get the unique elements of the tuple. All right. So initially word is empty, and what I'm trying to check, if this word is not there in this tuple, we will add it. Otherwise, we will not add it because we are trying to get unique elements in the tuple. So we are checking if T1, what is T1 in the first iteration? It is apple. T is this and T1 is apple. So we are checking if apple not in word tuple. Obviously it is not there because word tuple is empty. What it will do is it will add that word to the tuple. So this is an empty tuple and this is the tuple containing apple. So if you print here words, you will see what it is doing. Words or words, comma, words. You see in the first iteration it is adding apple. In the second iteration it is adding orange. But in the third iteration it is checking if apple not in words, but apple is actually there in words, so it will not add apple to this. All right. And lastly, what are we doing? We are checking what is the minimum of the numbers in numbers and what is the maximum, and we'll count the number of unique elements. So we are just doing length of word, and then we are returning what is the maximum of these numbers 1, 20 and 21, what is the minimum of this 1, 20 and 21, and number of unique word counts. So we are just getting over here in result. So result will have this tuple. All right. Therefore result will be a tuple. If you check print type result, and when you do this you will get class tuple. Why? Because this return statement is actually returning a tuple. All right. And in the last three prints I am just printing minimum number, maximum number, and number of unique words. All right. So this is one program how we are utilizing the power of tuples. And why are we using tuples instead of list? Because we don't want to get it mutated somehow by error or something like that. When this function returns, I don't want to alter the return whatever it has returned. It is what it is. The function has returned and I know it is correct, and I don't want to alter the elements of that return of that function. When you don't want to alter the data, you always use a tuple. All right. Is this okay?
Yes, sir. Okay, it's okay.
All right. So there is another data type in Python, or I can say data structure in Python called sets. And whatever we have encountered sets in mathematics, it is same as what we'll encounter here in Python. All right. You see, sets are unordered collection of elements. Lists and tuples were ordered collection of elements, but set is unordered collection of elements, which means you cannot index in list. First thing first, you will not be able to index in sets. All right. Each elements being unique. In mathematics also, the elements inside sets are unique. You will not be able to place two same elements inside the list. So suppose you want to place the number 1 inside the list twice, you will not be able to do it because those are same elements, and that will be replaced by just the unique element 1. All right. Meaning there are no duplicates. Sets are mutable. You see, list is mutable, sets are mutable, and we'll see dictionaries are also mutable. Tuples is not mutable. All right. So among the 4 data type which I told you, among them only tuple is immutable. Now when we are talking about orderedness, list is ordered, tuples is ordered, set is unordered, and dictionary is also unordered. So if you want to write it somewhere, you can write it. All right. Otherwise, when you work with this, you will able to understand why it is unordered and how it is unordered. All right. So I'll repeat again. Mutability. So there is two things: mutability and orderedness. So in mutability, only tuple is unmutable. Otherwise, list, sets, and dictionaries are mutable. And when it comes to orderedness, lists and tuples are ordered. Sets and dictionaries are unordered. All right. So sets are mutable, allowing for addition and removal of elements or items. Sets are valuable. This is all right. So we'll see how to create sets. So you see, when you want to create an empty set, you have a function called set parenthesis. So you say a is equals to a set parenthesis, and when you check type of a, type of A, then you will get set. So A is a set. All right. Now what if you want to create a set with some elements? So you can do that when with curly braces. All right, you can say 1 comma 2 comma 3 comma 4 comma 5. So this is a set. All right, and you will can check type of A and as well as you can print A, and you will see that it is actually a set. All right, you are getting curly braces. Now if you try to repeat some elements inside the set, suppose what are you doing? You are repeating some elements. So you're saying 1 comma 1 comma 2 comma 2 comma 3 comma 3. All right, and when you print A, you will get only unique elements inside the set. So these repeating elements will not be there inside the set. All right. Now if you have a list, so let me check if I have this list 1. What is this? Yes. So this is a list. Now you can change this list to set using this function set. All right. So when you say s is equals to set list 1, then this list 1 will be changed to a set. New memory allocation will be done. All right. So list 1 is not changed. List 1 is as it is, but you have got a new object inside the memory, which is a set. All right. Now you can add new elements inside a set using the function add. All right. So suppose you have a set, this set S. I have a set S. All right, and you want to add some elements, so you can do S dot add and say you want to add 99, and when you check S, you see 99 is added. Now we are seeing this in ascending order 1 2 3 4 6 7 99, but it is not actually ordered. All right, so if you want to do S4, you will get an error. All right, so it is not actually ordered. It is just showing you for visual purposes as in ascending order, but it is not ordered. All right, now you see if you want to add a string, say R, so it will be added inside the set. All right, so if you check this, the R is there, but or again it is unordered. Now there is a function, this is add, there is another function called update. All right, so you see I'll say s dot update and I'll pass a list. So inside update you can pass anything, you can pass a list, you can pass a set. I'll show you, but before that let me show you what update does. All right, so I want to add some numbers inside this set. All right, so it is 1 comma 2 comma 33 comma 9 4 comma 55. All right, and I want to add this. You see these elements are added. So what is the difference? In add you just can add only one element, in update you can add multiple elements. Now in update you can have multiple data types also. So you are saying that add this list, so since this list is added, I'll just modify a little bit. All right, okay, I can also pass a set. So this is a set, and if you do that, then also these elements will be added inside the set. All right, you can add negative elements as well inside a set. It doesn't matter, these are all elements, so it will be able to add negative element as well. Now you might ask, since we are not able to since we are not able to access the elements of a, not access, I can say index. Since we are not able to index inside a set, how will we extract the element of a set? So I'm not able to do S of 2. I'm not able to do that. It is giving me an error. So can anyone suggest me how can I able to extract the element of a set? It is not using a function. It is just using simple programming we have learned earlier. Try if you can, maybe. How will we able to extract element from this set?
we can match.
What? Sorry.
We if 2 is present in the set, then we can print.
Then you can have infinite number of elements inside the set. How will you check which element is there inside the set or not? You can do that. You can check 2 in S. You can do that. You will get true or false. But how many elements will you check? You will not be able to exhaust all the elements which are there, because it can be strings, it can be tuples, it can be anything, right? So what you can do is, actually, you see, set is also an iterable object in Python. So you can iterate over a set. So for I in S, you can say print I. So when you do that, you will be able to access the elements inside the set. All right. Is it okay?
But for iteration, then we need to see its location, right? I mean 0, 1, 2, 3, something like that.
No, you see, what it is doing is, this is an iterable object, and it is just extracting one element and then printing it. You see, when there are specific um, use cases of these data types. Whenever you want something where you think that set will work, then you will use a set. These are flexibilities in Python.
Okay.
If you want to index, then you can use tuples or lists. But in such cases, when you have specific use cases for sets, then you will go for sets. All right.
Okay.
Now there is, since you can add some elements inside the set, you can also delete elements from a set. So you see, we have a set called S, and I want to delete elements from this set. So there is a function called discard, s.discard. Let me discard 3. So when we do that, you see, when I printed this S, it did not print in ascending order. So it is actually, you cannot say will it print in ascending or descending order. You see, it is just randomly printed the elements inside the set. Now I want to delete the element 3 from this set. All right, so this is not a position, because sets doesn't have position. So it will say that delete the element 3. Now it has deleted the element 3. You see, 3 was there, and when you print S, 3 is nowhere in this set. But okay, let me move to remove, and then we will see what is the difference between remove and discard. So there is also a function called remove. So you can pass an element to this, say 14. So I want to delete this element 14. All right. And when you check, 14 is not there inside this set. All right. So it is actually modifying the set. It is not giving me, it is not returning me a new set. It is actually modifying the original set. All right. So the return value of remove and discard is none. Now you may ask, what is the difference between discard and remove? There is a very subtle difference, but it is a very important difference. You see, if you try to remove something from a set, some element from a set which is not there inside the set, then you will get an error. You see, you have removed 14, and when you try to remove 14 again, because 14 is not there inside a set, you will get an error. All right. Now discard works in a different way. If you say s.discard and pass 14 to it, it will not return anything, and it will just let it go. It will check if 14 is not there or not. If 14 is there, it will remove. If not, it will not give an error. All right. So this is where remove and discard has difference. All right. Now we have also seen, is this okay, remove and discard? All right. Okay. So we have seen a function called pop. We have seen a function called pop in list. So can anybody recall what does this function pop did? So I'll give one example, but you have to tell me what it will do. All right. So what is list one? Let me check. Okay. List one is this, and I'll say list one dot pop. So what will it do? I'll not run it. Before I'll run it, I'll ask you what it will do. What pop does? Can you recall? Are you not studying? please study. It will be difficult if I just go on and you are not refreshing your memories. All right. Anyone? All right. So pop is a function which actually removes the last element of a list. So when you do pop, and it will return that element which is removed. Moreover, it updates the list. All right. It does three things. It removes the last element from the list, modifying the original list, and it returns that element. All right. So when you check, you see 7 is returned and list 1 is modified. List 1 doesn't have 7. All right. Now pop is actually removing the last element from a list, but set doesn't have a last element. It contains the elements and it doesn't have a starting element and last element. Now what will pop do in the set? It will just remove a random element from the set. All right, so this is actually, I'll just show you what is S. This is S, and what pop will do, pop will just remove some random element from the list. You may say it is removing the last element, but this is not the last element. You cannot say which is the last element. So it will just remove any element from the set. All right, you can do again to check what it is returning. I don't know what it will return. You see it returned 1, so it removed 1 from the set, and when you check, see 1 is not there inside the set. Now there is one more function called clear, s.clear, and I guess clear is also there in list. You can check, but let me show you what it does with set. When you say s.clear, it actually deletes all the elements from the set, but the set remains, so it will be an empty set. All right. So when you say del s, when you are saying del s, where did I do del s? Initially I did, I guess. Yes, when I said this del t in tuple, or you can do that in set also. So when you do del, it will remove that item from the memory itself. But when you do clear, it doesn't removes the set from the memory. Instead, it removes the elements from the set and keeps an empty set in memory. All right. So this is the difference between del and clear. All right. I hope it is making sense. The difference between del and clear. I guess it will work with list also. So we can check. This is the list, and I can say list1 dot clear, and I hope it works. Yes, it works, and you can check. It will be a list in memory with no elements inside it. All right. Now we'll go to some mathematics, set operations, and before that we can take a break and we'll meet at 7:01. All right. So we'll meet at 7:01 and then we'll proceed.
Okay.
So I hope you are here. Let's move. So you see, if you are familiar with sets operation in mathematics, we have some operations like union, intersection, difference, set difference, and etc. All right. So you can do that in Python also. All right. So let me define two set. And if you are familiar, you can do that using Venn diagram also. That makes it more readable, or not readable, visual, makes it easier to visualize. All right. So I'll say set 1 and set 2. I'll just define two sets. So we have two sets, set 1 and set 2. All right. So what I can do is I can have union. So union union of two sets. You can say print set 1, and you should remember set is actually a keyword, so you cannot have a set called set. All right. So you should say some other name, and this or symbol, which we used in other language, that below backspace in place of backward slash set 2. All right. When you do this, you will have a new set which is actually the union of both the sets. You see, this is a new set which is a union of both the sets. Similarly, you can have there is one more function. So this is actually an operator. You can have a function also. That function is set1 dot union set2. So on this set, you are applying a function called union and passing this set as an argument. What are we doing? On set 1, we are applying a function called union, and to that function we are passing a set called set2. And when we do that, we will get a return value of this. All right. But set1 will not be modified. Set1 will be same. This function just returns a set which is a union of both the sets. All right. Similarly, you can do intersection. I hope you know what union means. Union actually means all the elements of both the sets we will combine, and if there are repeating elements, we'll make that as a single element. When we do intersection, so we'll only print the common elements, or we'll only, in the intersection, we'll only have common elements. So we will have set1, this and set2. So when we do this, we will have only the intersection. So only the common elements. 3 is common, 4 is common, and 5 is common, and 6 is common. So we have this set which is an intersection. Similar to union, there is a function called intersection. You can use that set1 dot intersection set2. When you use that, you will get 3, 4, 5, and 6. All right. So this is just returning a set. It is not modifying either set1 or set2. All right. Now there is something called set difference. If you know what it is, set difference. Set difference, what it is actually, you see, if you want to do set1, I'll just write first, it is set1 minus set2. This is the Python expression, but what it actually does is it will take set1. All right. Any questions?
No.
All right. So are you familiar with set difference, or otherwise I'll explain? Okay, let me explain. So you see, what it will do is it will take set1 and it will just remove the elements which are common in both the sets. All right. Or you can say yes, it is doing that. So it is just taking set1, whatever is in the front, it will take that set, and if you do minus another set, so it will remove the common elements. All right. So you see, it removed 3, 4, 5, and 6 and just gave you 1 and 2. If you do set2 minus set1, so it will just take set2 and remove the common elements of set1 and set2. It will give 7, 8, 9, and 10. 7, 8, and 9, and 10. It removed 3, 4, 5, and 6. Similar to union and intersection, there is a function in Python to do this, which is called difference. When you do this, it will return a set which is actually the set difference. It will neither modify set1 or set2. Now there is something called symmetric difference. All right. These are not necessary. These are only mathematical functions, and I don't think you will be using these much. But there is called some symmetric difference. It is set 1 and this exponent function, not function, operator, and set 2. So it is not an exponent operator in Python. It is an exponent operator in mathematics. All right. And when you do this, then you will get actually the elements which are not. So what it is doing is it is doing a union and then removing the elements of intersection. So it is just getting this union. So this is the union and removing the intersection common element. So it is removing 3, 4, 5, 6. These 4 elements, they are removing 3, 4, 5 and 6. So what it will give? 1, 2, 7, 8, 9 and 10. So 1, 2, 7, 8, 9 and 10. This is called symmetric difference. All right, so this is called symmetric difference. And similar to this, you also have a function called symmetric difference. Symmetric difference. All right, I am spelling it incorrectly. SYMME symmetric. SYMMETRIC. Yes, symmetric difference. All right. Now there are 2 more things to talk about, sets, and then we'll move to frozen set. And frozen set is also not very important. So you see, we know about subsets. So you can check if a set is a subset of another set. So you can define 2 sets, x is equals to 1, 2, 3, and we have already have a set 1, which is 1, 2, 3, 4, 5 and 6. All right. So I'm defining one more set, which is x, and you can check if x is a subset of S1 or not. So you can do x dot is subset and pass the second set, set 1, and you will get true. So you see, this is actually a subset of set 1. So this is all, and if it is not, then it will return false. So set 1 dot is subset set 2, it will return, sorry, it will return false. All right, because set 1 is not a subset of set 2. Now there is something called frozen sets. It is not super important, but as it is there, I should tell you. You see, set is actually mutable, but what if you wanted a set which is immutable? And in that, the concept of frozen set comes. You can define a set which is immutable. All right. So this is how it is defined. You have to say frozen set and then pass a list. So 1, 2, 3, 4 and 5. All right. So this is set 1 and I can say set 2 and I'll say frozen set. I'll just copy paste this and the elements I'll change a little bit. All right, so I've defined 2 sets, set 1 and set 2. You can check it is a set. You can see set 1, and when you do that, it will say a frozen set. Over here also, if you do type, I guess we did this, type x, it will say a set. All right. Now in frozen set, since it is immutable, you cannot use the functions which we used earlier. So you cannot use add or remove or something like that. All right, you will not be able to do that. And why do we need this? We will see when we go to dictionaries. All right, so you will see this. But since we're not able to use this, then what is the things we can do with frozen sets? You can do actually union, intersection, set difference, symmetric difference, and etc. with frozen sets. So you can do that. Set 1 union set 2. So you can do this, and you will get a frozen set, which the union of the elements. All right. So you can do all the other things. So you can do set 1 intersection, set 2, and you will get a frozen set. All right. Now we'll move on to dictionaries. Before going to dictionaries, I'll tell you. No, let us first go to dictionaries. All right. So dictionaries is also. Acha, any question in frozen set or sets? Set or frozen set? Any questions? All right. Then we'll move on to dictionaries. You see, I'm not very familiar with hash tables, so I'm not good in data structures, but there is something called hash tables in data structures. How many of you are aware of hash tables? Hash tables?
I don't know about.
All right. Ranjit?
I know little bit, sir.
Pardon? Sorry?
I know little bit, sir.
Okay. Ranjit? Pratibha? Do you know?
No, sir.
Okay, okay. So, all right. I'll just. So you see, what is a dictionary? I should actually show you in a. Just give me 1 second. All right. One minute. Just 1 minute. So I hope you are able to see my screen. Not use here. Just I'll use a. Yeah. Just.
Yes, sir. Yes.
Okay. Just give me 1 minute. Yeah. So you see, I have just made a note here. So what is actually a hash table is, you see, you will just have two, sorry, yes, you will have two columns and this will be known as keys and this will be known as values. All right. And in list you had index, but here keys will be your index. So suppose this is, and in key you can give anything. It can be an integer, it can either be a string, and it can be anything. All right. So instead of indexed like 0, 1, 2, 3, 4 in list, you can have keys. So these keys are actually some form of positional um, arguments of these values, and inside of values you can have anything like integers or strings, anything. Now when you have to index inside a dictionaries, you can directly say, I'll show you the notations how it uses, but you can directly say this key, whatever the value, you can extract it. All right. It is just a data structure where you are just identifying the values using keys instead of index. Moreover, this is unordered. So it is not that this key is first, this key is second, this key is third. It is unordered. All right. So it is unordered and it is mutable. So you can change the values of a dictionary. You can change the keys of a dictionary. You can just remove some key value pair. So this will always come up as a pair, key value pair. All right. So dictionary is actually a collection of key value pair. And whenever you want to extract some data from dictionary, you have to identify what is the key, and in that key it will check what is the value and it will give you the value of that key. All right. So this is a hash table in data structure, if I'm not wrong, because I am not very an expert in data structure, so I may be wrong, but this is what a dictionary is in Python. All right. So now we'll move on to my laptop and we'll see what and how we define this data structure, sorry, dictionary. Any doubt? I'm just disconnecting my iPad. All right. So I'll just share my screen over here. Okay. So just 1 minute. Yes. So we can define an empty dictionary using curly braces. So my, just a minute, my dict I will say, and I can say curly braces. Sorry, dictionary always is defined in curly braces. Now you may ask, if I am saying curly braces, why Python will not think this as a set? You see, when we had to define an empty set, you go back, you will check that we did not do it using curly braces for empty sets. You will go and you will see, for an empty set we had to use the keyword set parenthesis. It is not a keyword actually, it is a function. Nevertheless, we had to use this to define an empty set. But for an empty dictionary, you will have to say curly braces with nothing inside it. And when you check the type of this, type of my dict, then you will see it is actually a dictionary. All right. Now, how will you define key value pairs inside a dictionary? So you see, you cannot say dict, by the way. Dict is a keyword in Python, so I am saying just dict1. You will have a key and a value. So first you will say key. So I'm just saying 1 is the first key and the value is ONE. The second key is 2 and I'm saying the value of this is TWO. Similarly 3 and the value is 3. And you see, this is a colon and not a equal to. You might have faced this difficulty. I also do this several times. Instead of colon, I give equal to and it will give me an error. So it is a colon and not equal to. All right. So you have defined a dictionary with 3 key value pairs. First is 1, the key is 1 and the value is 1 and so on. All right. Now if you want to extract the value of the dictionary when you have the key as 2, you can do that. We'll see when we go to dictionary access. All right. Now keys can either be an integer or it can be a string or it can be other non-mutable data types. What I mean by this, when I say dict2 is equals to and I say ONE colon and it is anything value, this is key. I am saying this string ONE is the key and what is the value? Anything. Let me say 234 is the value of this key. And let me be more meaningful. So I'm saying Shubham is the key and the value is, see, I'm giving equal to, and the value is my height. Suppose 172 centimeter is my height. All right. Again, I can say Sagar is a person whose height is 165 centimeter. And I can say one more person as Raja, and his height is 175 centimeter. All right. You see, you can have keys as something which is immutable. So this is immutable. It is all right. Now instead of this, you are passing, you are giving a list. Suppose you are saying the keys. So we are talking about keys, not the values. You are saying that this is a list. And again, you are saying that I am saying one more something. Sun, anything. It will say unhashable type list. So always remember the keys of the dictionary should be unhashable or immutable. All right. And this is here why frozen sets are important. In the place of keys, if you want to assign a set, it is very rare, but still if you want to assign a set inside the dictionary in place of key, you will have to use set and not a, you will have to use frozen set and not a set. All right. Now inside the values you can have anything. It can be hashable, it can be unhashable. All right. So you can have a list as a value. So you can have something like this and it will be all right, no problem. Sorry, what did I do wrong? Okay, I did not assign it to something. Dict3. Now you see dict3 is being defined in memory, and when you go and check what is dict3, you will get this. Is it all right? Is it making sense? So this is the key and this is the value. You can think of it as a table. All right. So the first row, first column is Shubham, first column second row is Sagar, and the first column third row is Raja, and these are the values. All right. I hope it is all right.
Yes.
Now,
Yes,
since I was saying that keys should be immutable, so in place of keys you can have tuples also, because tuples are immutable. All right. So it is up to you and application. If the application is such that you have to have a tuple inside the for a key, then you can use. I'm just giving you cases where you might have a tuple as the key. It is up to you. It is up to the application where you are using it, but it will not give an error. Why? Because this is a tuple. All right. Now you can also have a tuple as value, because values can be anything. It can be mutable, it can be immutable, it can be anything. So it can be a tuple. All right, it can be a tuple. Now you see these keys are unique. You cannot have repeating keys. You cannot have two Shubhams in a dictionary, and you can it is very easy to understand why, because you cannot have so if you think of as a list, you cannot say that there are two elements with same index. It cannot happen. Similar to this, you cannot have two values with the same key. All right, you cannot have two values with the same key. So keys cannot repeat in a dictionary, but values can, because those are values. In a list, we repeated values, we repeated once so many times, two, so many times. Similarly, in a dictionary, you can repeat values, but you cannot repeat keys. So you see 165 is Sagar. I'll just make Raja 165 and it will not be an error. All right. But in place of Raja, if you say Shubham, then it will be an error, because you cannot have repeating. Okay, what did it do? Let me check what did it do. What? Okay, so what did it do? It replaced Shubham. So it said that it assigned Shubham this value, but again I'm saying that Shubham is this value, so it is just changing the value of Shubham. All right. So it means that you cannot have repeating keys in dictionary. All right. Now, if you have a list and you want to change it to dictionary, so suppose you have a list like this 1, 2, 3, 4, 5, 6, and this is 7. Suppose this is a list. Now you see it doesn't have a key value pair, so you cannot make this list as a dictionary. But if you define something as a key value pair, then you will be able to change it to a dictionary. What do I mean by that? You see, suppose you have a list 2 like this as tuples. So you are saying that 2 comma, sorry, it should be comma 4 5 or 4 comma 6, and one more tuple I'll give. It is sh comma 5. So this is actually a list with tuples. All right. Tuple object is not soluble. What did I do?
I think between
Okay.
2, 5 and 4, 6.
Yes. Thank you. Yes. So this is a list I defined. Now you can change this to a dictionary using the keyword dict, and you can pass list 2. And when you do that, then it will become a dictionary. I'll just assign it to some dictionary. Dict 3 is equals to this. And when you check dict 3, then you will have this 2 as the key. So you see, whatever is in the first position of the tuple, it will become key, and the other position will become value. So 4 is the key, 6 is the value, sh is the key, and 5 is the value. All right. So this is another way to create a dictionary. All right. So now we have seen many ways to create a dictionary and what should be the appropriate keys and values in a dictionary. Now we can access values in a dictionary. So I have a dictionary called, let me take this dictionary, dict3, and I'll say that this is my dictionary. You can check what is the dictionary. This is the dictionary. Now, so let me make this Shubham for simplicity. This is dict3. All right. Now I want to access the elements inside the dictionary. You can do that, and we have done this in list also. When we're using list, you just have to pass the key. So if you want to get Sagar, you have to just pass Sagar, all right, and it is case sensitive, all right. So you see, you will get the value. So this is how you access the values of a key. Now if you try to access something which is not there inside the dictionary, you see you are saying that Sagar Z, something like that, then you will get an error. It is saying key error because this key is not there inside the dictionary, all right. Any questions? Now you have some functions as well to get keys and values. You see, first you are trying to access, so there is a function called get, dict3 dot get, and when you do this and you say Sagar, then it will give you the value. Now in this, if you say Sagar Z or something like that which is not there in the dictionary, then it will not give an error. It will just check if the key is there or not in the dictionary, and if not, then it will actually give none. So if you print this, then it will give none. You see, it is none, all right. So this is how you access values inside a dictionary. Now you can add and modify elements inside a dictionary. I told you that dictionaries are mutable objects, so you can add and modify objects inside a dictionary. I'll just copy this dictionary and I'll print it. So this is dict3. Now you are trying to modify. Suppose you are saying that this value of Shubham is incorrect, you want to modify it. You can do that. You can say dict3, and you'll have to say Shubham, and you can just assign anything, whatever you want. I'm just assigning a string called S, all right. And when you do that, what happened? Cannot assign. Okay. This should be outside the, and you assign S, then you will get new. And when you do that, you have changed the value of the element which is in the key Shubham. You have changed the value of the element which is at the key Shubham, all right. Now if you are trying to assign some value to a key which is not there inside the dictionary, suppose you are saying Shubham 2 is actually shy, all right. Now you see Shubham 2 is actually not there inside the dictionary, and when you try to access it, you got an error. You see Sagar Z was not there inside the dictionary, and when you try to access it, it gave you an error, key error. You'll see it will give you a key error. But if you will assign some value to that key, then you will not get an error, but you will create a new key value pair, which is what you have defined, all right. So you will get Shubham 2 as shy, all right. So this is how you add or modify. You are adding, so this is adding, and here you are modifying elements to a dictionary. Now deleting or removing elements from a dictionary, all right. So we have seen defining a dictionary, we have seen accessing an element inside a dictionary, we have seen adding or modifying elements inside a dictionary. We will see how to delete or remove elements from a dictionary. So I have a dictionary dict3, and if I check, this is the dictionary, and I want to remove, and mind you, this dictionary is unordered, so you cannot say this is 0, this is 1 or something like that. In that case, if you say dictionary.pop, this will give you an error. Why? Because over here in set you just had to say pop, but over here you have to pass the key. So you are saying that pop Sagar, and when you do that, then the whatever the value of Sagar is will be returned. We have seen this when we used pop, and when you check what is dict3, then it will be modified, and that key value pair is removed from the memory, all right. Now there is a similar function, but it is pop item, all right. It is pop item, and there is nothing to pass to this function. When you do this, then what happens is anything in random will be popped, or anything in random will be removed from the dictionary. Anything, I mean any key value pair whatever any random key value pair from the dictionary will be popped. All right, so it just removed this. Coincidentally, it is the last key value pair, but it is not last because there is no ordering in dictionary. All right, now you can also use del keyword. We have seen del when you say dict3 and pass some key, say you want to remove Shubham, and when you do that, then that in the dict that key value pair is removed. All right. Lastly, there is called clear. So we have seen this clear. So dict3 dot clear. So when we do that, then inside the memory, the dictionary will be there, but it will be an empty dictionary. All right. When you check what is dict3, then it will be an empty dictionary. All right. And one very last thing, when you say del and give a keyword, and we have seen this what del does, it actually removes that object from the memory, and you will have a error. It says dict3 is not defined. Why? Because we have deleted dict3 from the memory. All right. Any questions?
No, sir.
Now we'll see some methods in a dictionary. Let me define a dictionary called SQUARE, and it will have some squares. So 1 square is 1, 2 square is 4, 3 square is 9, and 4 square is 16. I'll just move on a little bit. 5 square is 25 and 6 square is 36. All right. So this is a dictionary, and I'll show you some of the methods we can use in a dictionary. So first method is copy. So you can have a new dictionary, and you can say SQUARE dot copy. When you do this, then a new dictionary will be created inside a memory, and you can check in Python tutor what is happening. All right, I'll show you two things. It is important to realize what is happening. I'll just copy and paste, and I'll say new 1 square is equals to square. Now you will able to visualize what is happening. You see, I have defined a dictionary inside the memory, and you can see it is a key value pair. This is the key and this is the value. It is being stored like this. Now when you say new 1 square is equals to square, it will point to the same object in memory. But when you say copy, then it will create a copy inside the memory, and then it will point to it. Now if you make changes to this object will not change. All right. So this is how you make a copy of a dictionary. Any questions?
No, sir.
There is something called item. So you can say square dot item or items, I guess items. When you do that, then you will get what you will get. You will get an iterable object. It is not a list. You may see a square bracket, but it is not a list. It is an iterable object. What it contains? It contains key value pairs. So in the first key value pair you see 1 1, the second key value pair is 2 4, 3 9, 4 16, 5 25, 6 36. So it is actually an iterable object. If you want to convert it into list, you can do that. You can say list, and you can convert, and you will get the list. All right. So similar to range, what range does, it gives an iterable object. Similar to that, it gives an iterable object. All right. Now there is another function called keys. I guess keys. Yes, keys. It will give you the keys of the dictionary, and it is also an iterable object, not a list. All right. So it gives the keys 1, 2, 3, 4, 5, and 6. These are the keys. Similarly, there is another function called values. VALUES, values. And when you do, you will get the values of the dictionaries 1, 4, 60, 9, 60, 25, and 36. All right. You can also get all the other functions which are there in the dictionary. You can check. You have to define. I guess you can do this also. When you do this, you will get all the functions which are there in a dictionary. So these are the list of all the functions which are there inside a dictionary. All right. So for anything you can do, if you pass a string, you will get all the functions for a string. If you pass a list, you will get all the functions for a list using this keyword called dir. All right, this is it. Now we'll move on to dictionary comprehension. Dictionary. So if you remember list comprehension, it is similar to that. Let me see. Yes. So you see, you can actually first let me show you how to extract object from. So since you see, since dictionary is also a data structure, it is also an iterable object. You see, we have a dictionary called square. All right, and when we check, when you check, this is the dictionary. You can have a for loop for this dictionary, and when you do that, what you will have, you can see, you see dictionary. Okay, actually this is a dictionary, not an iterable object. You have to make it an iterable object. You can do that using square.items, and when you do this, then you will have the iterable object. You see, this is an iterable object, and in the first iteration it will have this, in the second iteration it will have this, in the second iteration it will have this. So you can see print I. When you do this, you will see first iteration I is 1 1, second iteration 2 4, third iteration 3 9, 4 16, 5 25, and 6 36. So from my side, any noise is coming, or is it all right?
I can hear some noise, but it's not disturbing.
Okay. Now we will show you some dictionary comprehension. So let me define a new dictionary called D. All right. So the first key is A, and I'll say the value is 1. The second key is B, and I'll say the value is 2. And let me define few more key value pairs. So are you able to understand whatever I'm doing? Because it might be very different from other programming languages, but you will see the power of these data structures later on. Any difficulty understanding?
Everything is new, so it's just settling in.
All right. So what I will do is I'll not move a lot in dictionary comprehension, because it gets complicated. You have seen in list also. Before that, I just forgot to tell you one thing. You see, in for loop, I is actually a tuple. It is actually a tuple, right? You see 1 1 2 4, it is tuple. So what you can do is you can have two values over here, I comma j. I comma j. Now it will just unpack. So one will come to I, and this one will go to j. Similarly, 2 will go to I and 4 will go to j. So you can check using this. You see I comma I and print j comma j, and when you do this, you will see I is 1, j is 1, I is 2, j is 4, and so on. So you're just unpacking the tuple in the for loop itself. So I just wanted to show you that you can do that here as well. All right. So I'll not go a lot in depth in dictionary comprehension, but I'll show you few things. You see, this is a dictionary called D, and you want to define a new dictionary. So you are saying new D is equals to, and what you want to do is you want to get those key value pairs in which the values is more than say 3. So you want to get, let me write it, get a new dictionary where from the dictionary D with keys more than 3 with so it is able to understand. I have not written in perfect English, but you are able to understand.
Values more than 3, right?
No, yes. Right. So I want to do this. Now you can use comprehension, dictionary comprehension to do this. All right. So you see, I can unpack the tuple itself over here. We can do that. So in for loop, you can unpack tuple. So we'll use this concept. All right. So first I'll say give me the key value pair. So I'm saying K is the key, V is the value. All right, and I am doing a for loop for K comma V. So I'm unpacking it in D dot items. So what it will do in D dot items, first this tuple will be assigned to K comma V. Second 2 comma 4, 3 comma 9, 4 comma 16, 5 comma 25, and 6 comma 36. So in this for loop, K and V will be these values. All right. Now I'll say for these values, I guess colon is not required. I will check. I don't remember if colon is required or not. All right. So I'll check for these KV, if V is greater than 3, then only you give this KV to the new dictionary. So what I am doing, I am saying the key value pairs KV for the KV in this items only if V is greater than 3. All right. So when you do this, you will get new D as, you see D is 4, E is 5. You can simplify this a little bit if it is confusing. So you can say new 2 and you will just remove this condition. If you remove this condition, you will see new 2D is actually all the key value pairs, because we have not given any condition. We are just saying KV and I'm just assigning that KV to the dictionary. So A1, B2, C3, D4 and E5. And in this I'm giving a condition. So I'm saying only if V is greater than 3, then you give this key value pair to the dictionary. Is it all right?
Yes, sir. Yes.
All right. So I'm thinking, should I move forward or not? Because I think I'll do this in later tomorrow maybe. All right. So this is it for today's class. All right. So I'll not move forward. Yes, this is it. All right. So what we have done is we have covered all the data structures which are necessary for beginners. And then we'll move on to maybe functions or recursions. We'll move on to recursions and more on functions in next class. So in today's class, we saw tuples, we saw sets, we saw frozen sets, then we moved on to dictionaries. And I have not given you any problems on dictionaries, but I would suggest that you should go through some problems in dictionaries. And if not, then I'll see if I can have some problems on dictionaries where the concept of dictionaries are more emphasized. All right. So I'll just mark the attendance. Just 1 minute. So can you give me some feedback? Is it going difficult or I am able to, or am I making it confusing, something like that, or everything is, you are able to understand something like that?
It's okay, sir. We need to practice.
Yes, sir.
Right. So Kalyavani ma'am is here, then Ranjit is here. Hello Ranjit, you are here because I couldn't, because you are not speaking today.
Yeah, I am here.
Ram Prakash is here and Pratibha is here. Where is Pratibha? Yes.
Yes, sir.
4 people are here today. Yes. So thank you. So in tomorrow's, not tomorrow's, in next class, we'll move back to functions. All right.
Okay.
Thank you, sir.
Thank you.
Thank you.